Our topic for today is transforming from rectangular or Cartesian coordinates to polar coordinates. So just a quick review. A Cartesian coordinate, it has two numbers, where the first number is the distance from the vertical and the second number is the distance from the horizontal. So for example, you have a Cartesian coordinate 4 and 3. 4 and 3, positive 4 and positive 3. So the first number is your distance from the vertical. I call it the left and the right. So this is positive 4, so it goes to the right 4 units, 1, 2, 3, 4. So it starts from here. And then this is the distance from the horizontal. So I call it up and down because it goes up and down. So this is positive 3, so it goes up 3 units. So 1, 2, 3. So this is your point 4 and 3. And now for the polar, we have two numbers as well. The first is the distance from the origin, and the second is the angle it makes with the polar axis. For example, we have a number 5 and 30 degrees. So we need to find first where is 30 degrees from the polar axis. So using a protractor, we get the 30 degrees, which is around here. So this is your 30 degrees. Yeah. And then you measure 5 units from the origin up to the point. So that would be 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is your point for the polar coordinate. So let's do some examples. So let's take the example 1 as at the first quadrant. So let's say this is your first example, 4 and 3. So this is quadrant 1. Now, so this is your point. So we need to transform it into a polar coordinate. So what we need to find is this distance to get the r. And then we can make this into a right triangle. So since this is a right triangle, we can easily solve for the angle for the polar coordinate. Now we have here, so this is 4 and 3. So this is 4 units here from the length of this one, and the height is 3 units. So we can solve for the angle using the trigonometric function tangent and using these two sides. So 3 is opposite and 4 is adjacent to this angle, so we use tangent. So tangent theta is opposite 3 over adjacent 4, or tangent theta is 0.75. Now so to get the angle theta, so we get the inverse tangent of 0.75. that would be 36.87 degrees. So your angle is 36.87 degrees. Now to get the r, so we use the Pythagorean theorem. So we have these two sides. So r would be the square root of the 3 squared plus 4 squared. So r is equal to the square root of 9 plus 16. R is equal to the square root of 25. So r is 5. So your polar coordinate will be 5 and 36.87 degrees. So this coincides with the Cartesian coordinate of 4 and 3. Example 2. For example 2, let's say we use the second quadrant this time. So this is on the first quadrant, so quadrant 2. So this is 1, 2, 3, 4. So example 2 will be on the second quadrant. For example, we have -5 and 2. So we look for the polar coordinate. So -5. So first left and right. This is negative, so we go to the left. 1, 2, 3, 4, 5. So it starts here, and then +2, you go up 2 units. So this is your point. Now, so we need to get the polar coordinate. So we just make a line from the origin up to this point. And then we can make a right triangle. So this is 5, and this is 2. So what we need to find is R and this angle. So this is, let's say this is alpha. Your angle would be from here to here. So this is the one that we would eventually need to find. This is theta. So this is alpha. Yeah. So we find alpha first. So we can subtract it. 180 minus alpha, you'll get your angle theta. So you have, so we can solve for alpha first. So tangent alpha will be opposite. So what's opposite alpha? Opposite is 2. Adjacent will be, adjacent to this is 5. So 2 over 5. So tangent alpha is 2 over 5 or 0.4. So tangent, inverse tangent of 0.4 is equal to 21.8 degrees. So this is your alpha. So to get your theta, the angle that we need, so we have to subtract 180 minus 21.8. So your theta would be 158.2 degrees. To solve for the length, the r, so we use this Pythagorean theorem again. So r would be the square root of 5 squared plus 2 squared. So that would be 25 plus 4 square root of 29. So that is your r. And then or you can so we can leave it the answer as it is, or we can say that it's 5.38 approximately, but this is a more accurate answer. So your polar coordinate would now be square root of 29 and 158.2 degrees. So that's example 3. We now go, let's say, have the third quadrant as our example. For example, we have the rectangular coordinate -6, -3. So this is your left and right. Negative, so goes to the left. 1, 2, 3, 4, 5, 6. And then -3. 1, 2, and 3. So this is your point. And then we can make a line from the origin to the point. I'll just make a better line. I might as well use a ruler. So that's a straight line. And then make a right triangle. So so this is 6, negative 6. This is let's say making it into a right triangle, it doesn't matter the sign. So this is 6, this is 3. So what we need to find is this angle. This would be your theta, always from the polar axis from here to here. So this would be your theta, and this would be your r. So you can use it like only for as a right triangle. So let's rewrite it into a right triangle. So this is your right triangle. This is 6, this is 3. So let's try to solve first this angle. Let's say this is beta. So we can solve for this angle. We can add this straight line is 180 degrees from here to here, and then we add the angle beta, so we can get the theta that we need. so we use again tangent to get the angle beta. So tangent beta would be equal to, opposite of this one is 3. So opposite is 3. Adjacent to this one is 6. Opposite over adjacent, yeah. So tangent beta is equal to 0.5. Now, so what we need is the inverse tangent. Tangent negative 1 of 0.5 would be tangent theta 0.5 would be 26.56. 26.56 degrees. Now to get theta, so we add 180 to this one, 180 plus just 26. So theta here will be 180 plus 26.56 degrees. So your theta would be 206.56. 206.56 degrees. So to get the r, again we use the Pythagorean theorem. R is equal to the square root of 6 squared plus 3 squared. So r is equal to 36 plus 9. R is equal to the square root of 45. 45. So it can be, you can get the square root of 45, or you can get 6.7, but this 6.7 is approximate, is there are more digits in here, so this is a more a better answer. So now your polar coordinate would be square root of 45 and 206.56 degrees. Fourth example, let's try quadrant number 4. So 1, 2, 3, 4. This is the fourth quadrant. Let's say our example is 4 and negative 4. For example, our Cartesian coordinate is 4 and negative 4. Yeah. Now, so this is goes left and right. This is positive, so we go to the right. 1, 2, 3, 4. So this starts here. This one is up and down. This is negative, so it goes down. 1, 2, 3, 4. So it's here. So it's approximately here. This is your point. Now, so what we need to get is this distance to get the r. And now your theta would be, you have to answer, you can have two options for your theta, but first let's get the, let's get this angle. Let's say this is gamma, angle gamma. And so this is your triangle. So to get this R, let's rewrite this triangle. So it's like a isosceles triangle, but still a right triangle here. So this is 4, this is 4. So we're looking for this angle. Okay, to get, let's say this is gamma. So tangent gamma is equal to opposite. So what's opposite? This one is this one, 4 over adjacent. What's adjacent to this one? Also 4. So your 4 divided by 4 is 1. So to get the angle gamma, so inverse tangent of 1 is equal to 45 degrees. So we got your angle. Now we need to get this R. So to get R is equal to the square root of 4 squared plus 4 squared. R is equal to 16 plus 16, or equal to the square root of 32. So we can leave it as it is, or the approximate one without the radical sign would be 5.65, although there are some more numbers, so this is some more correct form. So you get the length, you get the angle. So this is by the way, angle gamma. So what we have measured is only this one, but we have two options. So this is your theta from here all the way around here. So we can have two options. We subtract 360 minus 45. Yep. So 360 minus 45 is 315 degrees. 315 degrees. So your first answer is square root of 32 and 315 degrees. Now there's another, as I said, there's another option for an answer. So we can also do, in polar coordinates, we can also do a reverse rotation. So we can use a reverse rotation from the polar axis and going this way. But we need to use the negative sign. So from here to here, we know that it's 45 degrees. So another answer for this is square root of 32 and negative 45 degrees. So these are both the same location. It's the same point. So this is just the counterclockwise, and this is clockwise. So they are the same answer.